the date for the day. I'm going to leave the date off because I am recording these and I'm beginning to hope that you're doing these at night at home. Today's notes are lesson 2.2. It is again scientific notation. This time it is negative powers of 10. Then I will put the page numbers up here at the top. Pages... Oops, I lost the pages. through 44. Our essential question today: how can you use scientific notation to express very small quantities? Process for today is explained on page 39 of your textbook, and it is very similar to what we did yesterday with very large quantities. Here we have an example. A typical human hair has a diameter of 0.000025 meters. And we want to write that in scientific notation. This is a very small number. This number exists between 0 and 1. Okay? This is different from yesterday when the numbers were larger than 1. Today it's going to exist between 0 and 1. So we're going to start with our number. And over here on this side, let's give you some extra notes. Place the decimal again to the right of the first non-zero digit. Then you're going to again count how many places the decimal moved. So I'm going to start with my that's non-zero. I'm going to put my decimal in between so that it's to the right of the first non-zero digit. Then I've got to figure out how many places the decimal moved. 1, 2, 3, 4, 5. So I'm going to multiply by 10 to the 5th, only it's not a positive 5 today, it's negative, because this is a very small number. The decimal actually moved to the left, whereas yesterday it moved to the right. So if it moves to the left, it becomes a smaller number, so we need a negative exponent. let's do another example. We're going to write 0.000000302 in scientific notation. Again, you start with that number. And you're going to write down this part of the number, and that decimal goes to the right of the first non-zero digit. This is between 0 and 1, so I know it's going to be a negative number. And let's see, 1, 2, 3, 4, 5, 6, 7. So it's 3.02 times 10 to the negative 7. And just like yesterday, if we write in scientific notation from standard form, we can write standard form in scientific notation. So here is our first example for this. Our number is 2.33 times 10 to the negative 6. And we want to write that in standard notation. Remember, standard notation is the way that we would normally write a number without any shortcuts. And before I get into this, I'm going to add some notes here on the side for you. You're going to write the exponent number of zeros, then place the digits of the number to the right of the zeros. You will place the decimal between the first two zeros. This is how I learned it. This is how I teach it. Don't guarantee that this is the way it is in the book. So if I'm starting with 2.33 times 10 to the negative 6, what I do is I ignore the negative. I look at the 6. I want 6 zeros. 1, 2, 3, 4, 5, 6. Then I'm going to write this number without the decimal. And I'm going to put my decimal between the first two zeros. Now if I did this right, that decimal needed to move 6 places to the left. So let's see. 1, 2, 3, 4, 5, 6. And it worked. And I found that that works every time if I do it just like that. Let's do one more example. We have Jeremy, who measured the length of an ant as 1 times 10 to the negative 2 meter. And we need to write that length in standard notation. So 1 times 10 to the negative 2. I need 2 zeros and then the 1. And I put my decimal right there. 1, 2. It moved 2. So there is our answer there. And your assignment for today. 1, summarize your notes. 2, set up 3 to 4 more pages. And 3. Pages 42 to 44. Numbers 1 through 15 odd. 16, 18, 20, and then 24 through 36.